Hi, my name is G. Sachin Amingar.
Myself, Prithviraj Potam Shetty.
We have done project on solar-driven water management system.
In this solar-driven water management system, this project mainly includes water filtration for both domestic purposes and also for drinking purposes. And our project also includes the recycling of sewage water, wastewater, which comes from households or industrial wastages. Through this, we can eradicate the scarcity of water. We can reuse the water for further uses, and scarcity of water is avoided by using our project. Now let us move on to the filtration process. In this filtration process, we have sedimentation tank, sedimentation for carrying sedimentation process, and a coagulation and a flocculation tank. An activated charcoal chamber. Finally, we have a storage tank. Now coming to the source for our project is this source. From this we'll be collecting the raw water to the sedimentation tank, and you can see here the water present in this sedimentation tank. That is the sedimented portion, which you can see at the bottom of this tank. In this sedimentation, the dense particles, the particles which have higher density, moves downwards and settles at the bottom of this sedimentation tank. After the sedimentation process is completed, we will be sending this water to coagulation and flocculation tank by opening this valve. You can see the water flowing into this coagulation and flocculation tank. Now we have to add a coagulant for this coagulation tank. The coagulant we are taking is aluminium potassium sulfate. Now let us add an amount of alum for this water. By letting this water undisturbed for 5 to 6 hours, the particles which are having very smaller sizes are binded by that coagulant, by that alum together, and it lets that smaller particles come together, and then those particles are settled down at the bottom of this coagulation and flocculation tank. In the sedimentation tank, most of the particles which are having tiny size, smaller size, may not sediment at the bottom. By using this coagulation process, we are able to make the very smaller particles settle. Coagulation process has been completed. We have to open this valve and let the water to enter into this chlorination tank. And in this chlorination tank, we will be killing the harmful bacteria. If any harmful bacteria and viruses are present in this, which causes diseases and infections, we have to kill that bacteria in this chlorination tank. As a disinfectant, we are adding chlorine, liquid form of chlorine we are taking. You can see this is the liquid form of chlorine water. In other words, we have to add 0.5 ml of chlorine for 1 liter of water. Now let us add in that water. Letting that water undisturbed for a while, the bacteria and viruses and harmful bacteria are killed in there, which are present in that water. After the chlorination process is carried out, we have in this water, if we have high hardness, the water which we have taken having high ppm levels, then we have to add sodium carbonate anhydrous. Sodium carbonate anhydrous. By adding this, we can reduce the ppm levels. The amount which we add is depends on the how much hardness in the water. Then by adding this, we are able to reduce the hardness which is present in this water. What is the use of adding this or reducing the hardness in water? Generally, if we have high hardness in water, it leads to the high consumption of soap, and it may lead to wear out of utensils, so that it is required for us to add some chemicals like sodium carbonate for the reduction of hardness. After the chlorination and the reduction of hardness in this water is completed, we can use this water for domestic purposes like washing clothes and washing utensils and for bathing, etc. By opening this valve and this thing, we will be sending this water for domestic purposes, and we can, by closing this valve, we can restrict the water flow, and through this pipe we are sending the water for further purification for drinking purposes. This is the activated charcoal, in which the water gets effectively purified, which is useful for drinking. In this activated carbon or activated charcoal chamber, we have to add powdered activated charcoal. Here you can see the activated carbon, which is in powder form. Now let us add an amount of activated carbon, which is in powder form, to that activated charcoal chamber. The use of this powdered activated carbon is, if any microorganisms which are present in this water, our activated carbon will remove those microorganisms, and it also removes the poisonous gases. It absorbs the poisonous gases which are present in this water, which cannot be removed by the process of coagulation, flocculation, and as well as in sedimentation. After the filtration of water is completed in activated charcoal chamber, we have to open this valve for letting the water into the storage tank, so that we can drink this water. Before using this water for drinking, we have to add a pinch of calcium fluoride, which is used to stop the decay of teeth. Let that water undisturbed for a while, and then we can use that water for drinking. After adding calcium fluoride, this water is used for drinking. According to our measurement, the ppm levels in this water is about 45, and now we can use this water for drinking.